Hi everyone, my name is Sophia Chavez, and today we're going to be going over nomenclature and naming organic compounds with multiple functional groups. What are organic compounds? So they are chemical compounds composed of carbon rings or chains that are covalently bonded to usually hydrogen, nitrogen, and oxygen. As you can imagine, there are so many possibilities of compounds, so a naming system is necessary to distinguish all the different kinds of compounds. And the main system that we use is what we call the IUPAC nomenclature system. And this system is so effective because it also gives the molecular structure, and it does three main things. It specifies the carbon ring or chain, it specifies the functional groups in the compounds, and it also names the substituent groups. Functional groups are the groups of atoms attached to the carbon ring or chain that give the compound its properties, and compounds with these same functional groups share similar properties and characteristics. Rules for naming. So firstly, we must identify the main carbon chain, which is going to be the longest chain, and the functional group of highest priority must be on this chain. We will go over the list of priority shortly. Secondly, we must identify all the functional groups and as well as the substituent groups that will be attached to the main carbon chain. Thirdly, we're going to number the carbons in the main chain so that the functional group of highest precedence has the lowest carbon number. And then lastly, we're going to put the name together and we're going to list the substituents in alphabetical order with the locant coming before the name. And if two of the same substituent group is on the carbon, we're going to place di or tri in front of that name. Going over the basics, we have hydrocarbons. We know that they're composed of carbon and hydrogen, and if they have no double or triple bonds, we will call these alkanes. They're named in a two-part system with the stem or prefix pertaining to the number of carbons. So a simple example, if we have 3 carbons, we're going to call that propane. If the hydrocarbons are in rings, we place cyclo in front of the name. And then next we have our alkenes and alkynes. So if we have a double bond, we use the suffix "ene." So for that first example I gave, propane, we're going to change that to propene if it has a double bond. And then for triple bonds, we're going to change the ending to "yne." Moving on to alkyl and alkyl halides, they're both treated as substituent groups and they're added to the beginning of the name as a prefix. So we have our alkyl halides. So if you have the element fluorine, you're going to change that to fluoro. And if you have chlorine, you're going to change that to chloro. Same with alkyl groups. If you have a side chain that is composed of 2 carbons, let's say, you will call it ethyl. And they follow the same stem or prefix as your alkanes. Okay, moving on to alcohols. They have a hydroxyl group, an OH, and in order to name them, we're just going to change the ANE ending with anol. And if it were to have a double bond, so it had an ENE ending, we're going to change that to enol. If there's multiple alcohol groups, we're going to put di or tri in front of it after specifying their location. And if there is another functional group that takes precedence over the alcohol in the same compound, we're going to name it as a substituent group, giving it the substituent group name of hydroxy. Moving on to ethers, they have the formula ROR, but the R simply stands for the hydrocarbon chain or ring attached to the oxygen. So it's going to have 2 different types of groups, or it could be the same, attached to that oxygen. And to name them, there's simply a space put between the 2 names and ethers put at the end. And if there are the same alkyl group, so here at the top we can see it has dimethyl ether, then you're going to put a di in front of that name. And as a substituent, it is named oxy as a suffix. Okay, so our aldehydes and ketones. So these are both going to contain a carbonyl group. The aldehydes are going to replace one of the R's with a hydrogen, whereas the ketones are going to have the both R's as alkyl groups. Aldehydes are given the suffix al, while ketones are given the suffix ono, and both the substituents are given the name oxo. So as we can see here, as a simple example, methanol would have been methane, but as we have that carbonyl group, we're going to name it methanol, replacing the E with an Al. As well as here, we have propanone. As you can see, 3 carbons would have been propane, but because of that carbonyl group, we're going to put that as propanol. Okay, next we have our carboxylic acid. So this is going to have your carboxyl group, which is just a carbonyl group with also a hydroxyl group. And this one is actually going to take precedence over all other functional groups, and we're going to give it the suffix anoic acid. Here's a simple example. We have 1, 2, 3, 4 carbons, that's hence the boot. and then we're going to place the ending with enoic acid. Okay, so next we have esters. So this functional group consists of two components. We have an alkyl group and we also have our carbonyl group. And as you can see here, attached to our oxygen, we'll have some type of grouping here, as well as on this one, another group as well. So for naming, the alkyl is named as a substituent group. So whatever is attached to the O, we name as a substituent group. And then from the other side, attached to the carbonyl group is going to be what takes the O8 ending to it, kind of you can think of as the main chain, even though this whole thing is the main chain. But here, for example, we have methylpropanoate, so he has 1, 2, 3, 3 carbons, hence the prop. Then we have a methyl group here, 1 carbon, so we're going to have methylpropanoate for the ester. Next we have our amines. So these are organic derivatives of ammonia, NH3, and they can either be primary, secondary, or tertiary, and that depends on the substituents attached to the N atom. So we have primary amine, secondary, and tertiary. As a substituent is named amino, and if it has one alkyl group, it's going to be attached to the N. And then if any other ones, if it moves to secondary or tertiary, it's pretty simple. You just add the N as the locant in the front. So as here you can see that it has a methyl group attached, so it's N-methyl propanoate, hence 3 carbons, 1 amine. Okay, next are amides. So in this one, we're going to replace the hydroxyl group that would have been in a carboxylic group by NH2. And for naming, we're going to put it as an amide, which replaces the ane. In a substituent group, if that's attached to the N replacing the H, the N is put as the locant. And here we can see that we have 1, 2 carbons, so ethane. But we do have the enamide group right here, so we have ethanamide. And then we have 2 substituent groups attached to the N, so it's going to be dimethyl NN. Sorry. So all of that together will be NN dimethyl ethanamide. Okay, so here we have our listed of priority, and this is really important to keep in mind when you're naming or drawing out these structures. As you can see here, our carboxylic acid takes precedence over all of these different kinds of groups. So for example, if you had an alcohol and a carboxylic acid on the same compound, you would not use the OL ending, you would use the OIC ending, and you would use the hydroxy, so the alcohol, as a substituent group instead. Okay, so now we're just going to go over some practice examples. So we have, to make the longest carbon chain, 1, 2, 3, 4, 5. So we're going to go with pentane. Then we're going to identify the functional and substituent groups. So here we can see that we have our carboxylic acid. Here we have an alcohol, and here on the side we have seems to be an ethyl group with 2 carbons. Numbering them so that the group of the highest precedence, the carboxylic acid, takes the lowest carbon number. We're going to go 1, 2, 3, 4, and 5. And with that, we're going to give the name 3-ethanol 2-hydroxy pentanoic acid. Moving on to the next one, we're going to count out our carbons. 1, 2, 3, 4. Okay, so that's going to give us butane. And now identifying our groups, it seems here that we have an amide and here an amine. Numbering them so that the amide takes the lowest number of carbon. We have 1, 2, 3. We're going to give it the name 2-aminobutanamide. Moving on to our last one here, we're going to count it out. 1, 2, 3, 4. It seems to be our longest, so we're going to have butane. And now we're going to identify our groups. So here we can see that we have an amino group. Here we have an alcohol. Here a methyl group. And then here a double bond. Numbering them so that we get the lowest for the amine, which is going to be of our highest precedence. It's going to be 1, 2, 3, 4. And we're going to get the name 1-amino, 2-methyl, 3-butene, 2-all. Applications of organic nomenclature. So evidently they help you distinguish between different types of organic compounds while at the same time giving you the structure of the compound, and this is so important because, as I said previously, functional groups share common properties. So for example, alcohol, it has the shape of water, so it's bent, which makes it polar and allows for hydrogen bonding, which obviously affects the boiling point. And another example is carboxylic acid tend to have higher boiling points and are polar. And this is important for chemists and scientists because this way they have an idea of the compound that they're working with and how it'll react. Real-world uses of organic molecules. So here I've inserted this quote that really emphasizes the importance of functional groups and their usage in modern medical chemistry. The concept of functional groups that determine the intrinsic reactivity of the parent molecule and in part are responsible for the overall properties of the molecule form a foundation within modern medical chemistry. So as we know, functional groups share common properties as we've just discussed, and this permits drug molecules to perform their intended job. For example, the duration of time or overall solubility. And there are three main criteria to be considered in a functional group when using it in drug production: electronic effect, solubility effect, and steric effect. And so evidently nomenclature is essential for all of this because nomenclature specifies the functional group, it specifies substituent groups, it specifies the structure of the molecule, which is of organic molecules, which is going to be so important, especially in pharmacy and medicine, where the impact or presence of a functional group is so important. And to conclude this presentation, here are some links if you want more information on nomenclature. Both of these links helped me out in putting together this presentation, but the University of Calgary has really good explanations on nomenclature and the rules, as well as some practice examples that you can go through for further practice. Thank you so much for watching.